So today we're going to concentrate on making sure we know how to solve logarithmic equations. So on the back of the first page, we're going to start here with logarithmic equations. Tomorrow we'll be dealing with exponential equations, a little backwards. To solve a logarithmic equation, you're going to use the following properties, but you've got to make sure that you have the same base. So you're going to use logarithms, but you've got to make sure that they have the same base. So the property is, if you have log base b of something equal to log base b of something else, then you can say that those arguments are equal to each other. So log base b of x equal to log base b of y, then that means whatever this argument is has to equal this argument. We're going to check our solutions. When we practice checking our solutions, we're going to be ready for that test on Wednesday. Because when you check your solutions, you review all the previous properties we've discussed this chapter. So first example. You need to insert parentheses on your paper. Those were not there. And if the parentheses were not there, this problem's going to be a lot more difficult than what we need to do in Algebra 2. So be sure you insert parentheses everywhere. On the previous, or in that box that you had written down, if you have the same logarithm, base b, on both sides, you can just zoom in on the arguments. So notice how I have log base 3 on both sides. So that means I'm just going to zoom in on those arguments being equal to each other. If you have the same logarithm on both sides, zoom in on the arguments. They have to match. When we check, we're going to plug in 2 wherever we see x. So we have log base 3 of 5 times 2 minus 1. And we're asking ourselves, I'm going to keep this question mark, because that's where the question happens. Is it equal to log of 2 plus 7? So after simplifying the parentheses, well, yeah, the left side actually does equal the right side. This does check. All right, next example. Please insert the parentheses. You're missing them. Can't use this property without them. Go ahead, do this example, and then check with my answer up here. So we find it's -2 going through the check. So we get log base 4 of 1. Yeah, so it does check out. When it's not convenient to write both sides of an equation as logarithmic expressions with the same base, you can exponentiate each side of the equation. I may have made up that word, but I don't know how else to describe it, because exponential form or exponentials undo logarithms. I saw people on the last quiz try to divide logarithms on both sides. Bad thing is, division does not undo a logarithm. Think about what division undoes, because you know it. Division undoes multiplication. So logarithms and exponentials undo each other. You're going to see how if we have something equal to something, if x equals y, then we're going to raise them to be exponents of the same base. That's what exponentiate is going to mean in this class. We're going to raise both sides to be exponents of the same base. Let's use this property. So in example 9, we're going to use this exponentiate process. But I need a particular base to raise it for. So I'm going to take both sides and raise it to be powers of 5. Look at the notation. Log base 5 of 3x plus 1 now becomes an exponent of base 5. I'm going to do that to both sides. So that 2 also becomes an exponent of 5. This is what exponentiating means. You do it to both sides. Because there's a special property. When you have a base raised to a logarithm of the same base, these operations undo each other. And you're left with the argument 3x plus 1, and then 5 squared is 25. So when you exponentiate both sides, 5 to the log base 5 undo each other, and you're left with 3x plus 1. So in this check, we have log base 5 of 25. And we got to ask ourselves, is that going to be 2? So doing the circle, 5 squared actually does. It is equal to 25. This does check out, so x equals 8 is my answer. If for some reason this did not check out, that means we did something wrong. Or we have a no solution. You might find one of those in homework, where you do all the right steps. You're like, man, I'm coming up with the right stuff. I keep rechecking my work, but it's not coming out in the check. If it does not check out, sometimes we might get no solutions. Those are few and far between, but that is a possibility. Next example. Some of you haven't been waiting on me, so good. You keep going. We're going to have to exponentiate, meaning we've got to take both of these sides and set them to become exponents of a certain base. Both sides become exponents of 4. And I notice on this left side, 4 to the log base 4 undo each other. And I'm left with x plus 3 on the left side equal to 16. Going through the check. Log base 4 of 13 plus 3. You've got to ask yourself, is log base 4 of 16 actually equal to 2? 4 squared actually does equal 16. So x 13 is my answer. We're going to only do one more example today. We're only going to get one more in, and it's actually hard. So if you already started working on it, it's hard. No parentheses are there. We only have 2 properties. One of the properties says if you have a logarithm equal to a logarithm, the bad thing is we have logs, plus symbols, we have a minus symbol. So we actually can't use our properties that we've done so far because I see a plus and a minus here. I've got to get rid of these somehow. Here's how we're going to get rid of them. First off, if you notice the constant, minus 1 is a constant, or negative 1 is a constant. Let's get our constants together. So we get common log 5x plus common log x equals 3. Now the question is, how do we get rid of that plus sign? So we should, in order to do our formulas, or in order to do our rules, we have to have a logarithm equal to a logarithm, or a logarithm equal to a constant. We can't have a plus sign here. We got to condense. We have to use the product rule, undo the product rule. I see a plus sign between 2 logarithms, so to condense them, I'm going to have one logarithm of their product, 5x times x. And I can clean that up. So instead of 5x times x, I could call it 5x squared. Now I have a logarithm equal to a constant, like the previous example. I just got to figure out what is the base that I'm going to use to exponentiate both sides. I'm going to use 10. I'm going to make these exponents of 10, and I'm even going to put in the log base 10. That way we know that that's definitely common log. So both of these are going to be powers of 10. And I notice on the left side, wait a second, 10 to the log base 10 undo each other. And I've got 5x squared equal to 1,000. Try to start undoing this. And without getting a decimal, because when you take the square root of 200, you get a decimal. Let's remember the factor tree. See if you can remember Chapter 7 to refresh our skills. Chapter 7, we're looking for pairs. Pairs in 200. So you start doing the factor tree. You should be getting a pair of 5s and a pair of 2s. So this becomes, well, if you take out a pair of 5s, take out a pair of 2s, those multiply to be 10, and you're left with a 2 inside. Homework tonight. I want you to do, it's called Day 13 on the assignment sheet, and I want it to be 8.6 Day 2. It's problems like, they're like problems 43 to 51. So it's not even 10 problems. I think it's 9, 8, I can't remember. So be sure you look at that homework.